Bismillah Rahman Rahim. Guys, this is the next lecture, and I will continue with this valence shell electron pair repulsion, applying formula to calculate shape and angles. So, uh, if we look into the certain points, the first very important point is that what is the importance of valence shell electron pair repulsion models. Now, so far, Lewis structures, they can only tell the number and types of the bonds between atoms. And of course, they are limited to 2 dimensions. Now, this VSEPR model predicts the 3D shape of molecules and ions, but is ineffective in providing any specific information regarding the bond length or bond itself. Okay, now this VSEPR models, they are actually based on the concept that electrons around a central atom will configure themselves to minimize repulsion, and that actually dictates the geometry of the molecule, and this is very important. Further, it can also predict the shape of nearly all compounds that have a central atom, as long as this central atom is not a metal. And each shape has a name and an idealized bond angle associated with it. Now, we are going to see the following terminologies in the upcoming discussions. For example, the first terminology is bond angle. So this is actually the angle between a bonded atom, the central atom, and another bonded atom. So you should know about the bond angle. And I have already explained to you about the different bond angles in different shapes. Molecular geometry, this is the 3D arrangement of bonded atoms in a polyatomic ion or molecule. We'll see in the upcoming discussion. Then we come to the electron pair geometry. This is the 3D arrangement of electron pairs around the central atom of polyatomic ion or molecule. Again, this is the thing. So the main difference between molecular geometry and electron pair geometry is that molecular geometry does not include unpaired electrons, whereas electron pair geometry includes both bonded atoms and unpaired electrons. If there are no unpaired electrons in the compound being assessed, the molecular and electron pair geometries will be the same. Okay, so this is a basic introduction to understand VSEPR valence shell electron pair repulsion, applying formulas to calculate shape and angles. So let's start with it. So first is that simple molecules. So these are the molecules, and there are no non-bonding electrons. There will be no lone pairs. Okay, and there are total 5 basic shapes. Now we are going to see these five basic shapes when there is no lone pair. Okay, so for example, if I talk about methane, so methane CH4, there is no lone pair. Ammonia has 1 lone pair. Water has 2 lone pair. Okay, and any compound with the halogens like CHCl3. So 3 chlorines are there, right, with so many lone pairs. So I'm not talking about here any structure which is having lone pairs. And due to the presence of lone pair, the original shape is distorted to some new shape. So here, right now in this lecture, I'm only giving you the information about the 5 basic shapes when there is no non-bonding electrons. Let's come to the first thing. linear bond angle, linear shape, and bond angle is 180. This is the structure. Okay. So nearly all diatomic molecules are linear. So molecules with two atoms, let's see, this is atom number 1 and this is atom number 2, right? So these are the two atoms which are connected to this central, and the angle is totally 180 degrees. Shape is linear because these two fluorines, they are positioning opposite to one another in order to minimize the electron repulsion, right? Then we come to the generic formula for linear shape. Now this is the generic formula MX2, where M stands for central atom and X is or are the bonding atoms. And in the this is the what is the general formula for this structure and this shape? This is M for boron, okay, central में है ये, right? और X क्या है? जो लेजेंड्स इसके साथ अटैच्ड हैं, दो फ्लोरीन्स अटैच्ड हैं. हाउ मेनी? 2. सो MX2 जो है, दैट इज द फॉर्मूला फॉर लीनियर शेप. सो लीनियर शेप का जेनरिक फॉर्मूला वेस्पर से क्या है? व्हाट इज द फॉर्मूला? M for central atom and X to the two attachments which are attached to the central atom, right? Next, this is the structure, right? 180 degree linear shape. Next, we move to trigonal planar bond angle 120. Now the example is BF3. So from BF3, just looking at the BF3, we can calculate the formula, and that would be M, okay, X3, where M is the center atom and X3 are the three legends. So here I'm using the value of X as fluorine. So three fluorines are linked to the central boron. The shape is trigonal planar because electron repulsion is minimized by positioning the three attachments towards the corners of an equilateral triangle. Now let's see how this is the structure, right? So this is the center boron, and the three positions at the three fluorines, they are positioned at maximum distance from one another, and the angle is 120. Okay, so the formula is MX3, where M is the center and X3 is or are the bonding atoms. This is the name of the shape is trigonal planar, generic formula MX3, where M is the center atom and X are the bonding atoms. Two shapes hogi. Let's go to the third one. So third one is known as tetrahedral. So this is the name of the shape as per the VSEPR, and the bond angle is 109. So this is the shape. This is the shape you can see. And these four hydrogens are positioned in such a way so that they can be from maximum distance from one another. So generic formula, just by looking at the shape, we can understand the generic formula. C is M, this is M, okay? And how many X are there? 4. So MX4, where X are the 4 hydrogens. Okay? Angle is 109.5. So whenever the shape is tetrahedral, okay, the bond angle will be 109.5. So third shape is tetrahedral. Then we move to the fourth shape, that is known as trigonal bipyramidal. So फॉर्मूला हम इसमें देखेंगे, ठीक है? अब हम फॉर एग्जांपल by looking at the red PF5, we can make the formula mx5. It means that the center atom is this M, and there are 5 attachments which are linked to this center. So shape is known as trigonal bipyramidal. 3 of the attachments are positioned in a trigonal plane with 120 bond angles. अब जब 5 आ जाते हैं, जब 5 attachments हैं, तो 2 types के bond angles are there. Okay, generic formula आपका है mx5, where m is the central atom and x are the bonding atoms. Now this is the shape. Let me see. Yes, this is the shape. Okay, and what about the bond angles? So bond angle within the equilateral plane is 120, and bond angle between equatorial and axial plane is 90. Now let's see where are these equilateral plane and equatorial axial. So ये आपके हैं दो जो shapes हैं, जो angles हैं, this one 120 and this one is the 90 degree. Or I can say that this one 120. This is the 120. Let's see where is the 120. This is the 120 and this is angle 90. So the angle आपका जो है यहाँ पर bond angle 120 वो equilateral position में है. So this is the equilateral plane, and bond angle between equatorial and axial plane. Equatorial and axial plane, the bond angle is 90. Okay, so these are the 2 different angles which are found in trigonal bipyramidal. Next आप आ जाएं. This is the trigonal bipyramidal. Next आप आ जाते हैं octahedral, और bond angle इसमें all the bond angles they are of 90 degrees. Formula अगर आप इसका ले लें तो वो आ जाएगा m, okay, m x6, right? Bond angles 90. Name of the shape octahedral. So molecules with 6 atoms around a central atom such as SF6 are octahedral, having octahedral shape. 4 of the attachments are positioned in a square planar with 90-degree bond angles. Now let's see 4 of these. 1, 2, this is 3, and this is 4. ये 4 जो हैं अगर आप इसको ड्रॉ करें तो ये एक स्क्वायर बनता है. ओके, लाइक दिस. तो इस स्क्वायर के 4 जो है उनका एंगल जो है वो 90 डिग्रीज है. Right? Generic formula mx6, where m is the central atom and x are the bonding atoms. ये आप octahedral में example देख लें. SF6, the one fluorine with 6 electrons, all the shape electron pair geometry है ये, ठीक है, and this is the molecular geometry. These are the angles, square angles आप देखें. These are the square angles, ठीक है, these are 150 bond angles. Structure is octahedral. आप ऐसे देखते हैं कि ये this is like this, okay, square, and then you connect like this. So this is the octahedral shape. What's the difference in these two diagrams, in this electron pair geometry and molecular geometry? Electron pair geometry mein you have to show all the bonding and non-bonding. Here you just show the bonding one, right? Next, octahedral ka bond angle 90. The remaining 2 attachments are positioned perpendicular to 90 degree to the square plane and opposite ends of the central atom. Now you can see the remaining 2, जो ये this one and this one, this one and this one, ये just opposite होगा. One on the upper side of the square and one towards the lower side of the square. This arrangement of atoms minimizes repulsion. What is the main objective of having these shapes? So actually, these attachments must be at a distance in which the repulsion is minimized. So minimum repulsion आपने रखनी है, right? Then we go to angle. So this is the structure, octahedral structure. आप इसको draw कर सकते हैं, right? Like this. Okay. You can draw the structure like this and you will get the octahedral structure. So these are the 5 basic shapes. Okay. So I hope you understand these 5 shapes, and the next lecture will be about the how can you see the electron density in these 5 shapes, and I will upload that lecture tomorrow. Okay, thank you so much.